Alright, let's look at a problem that's a PV equals nRT type problem. And in these problems, we're given, for example, this one, find a pressure in torr of 80.8 grams of neon at 30 degrees Celsius, occupying 800 mils. And you can tell that this is not a combined gas law problem because there is no mention of a second set of conditions. Also, the fact that you're dealing with grams or moles is often an indication that we're dealing with a PV equals nRT type problem. In these instances, what we do is we're given the value of R, and all the units have to match the value of R, otherwise they won't cancel. And the value of R that we're going to use is 0.08206 litres atmospheres per mole per Kelvin. So this value is a constant value, and it's going to have different values depending on the units we're using. Now, since we're using the litres, atmospheres, moles, and kelvins, this is the value we're going to be using for R, 0.08206. Alright, so that's what we're going to have to do. If we're given the pressure in any other unit, we're going to have to convert to atmospheres. The volume is going to have to be converted to litres. We're going to have to have moles and not grams of substance, and we're going to need temperature to be in Kelvin. Alright, so let's look at how we might do this. Find the pressure in torr of 80.8 grams of neon at 30 degrees Celsius, occupying 800 mils. So what we do is we set this out. We've got P equals V equals N equals R equals T equals. That's the best thing to do because we know we need to use PV equals nRT. P is what we're looking for, so that gets the question mark. We've got 800 mils as our volume, but we know that that needs to be converted into litres, so that's why it's times 1 litre over 1,000 mils, and we come out to 0.800 litres for that. And we're obeying significant figures here. That's 3 sig figs, that's 3 sig figs as well. Now the number of moles was 80.8. N is going to be based on the number of grams, so 80.8 grams of neon times 1 mole of neon over 20.2 grams of neon, where 20.2 is going to be the molecular weight of neon. We get that off the periodic chart. So we're going to come out with 4.00 moles of neon as our answer there. So again, what we've done is we know that the pressure is going to come out to atmospheres. We know that the volume has to be in litres. We've got our N as moles now, and now we need the temperature to be in Kelvin. So we've got 30 degrees Celsius, we add 273.15 K, we'll get 303 K. Again, with the significant figures, this is addition, so we're looking at 0 decimal places and 2 decimal places. This comes out to 0 decimal places, so it's 303 K. Now what we can do is plug all this in. We've got our PV equals nRT. We isolate P, and what we're doing here is dividing both sides by volume, so it will be nRT over V. The other way of looking at that is that we're taking the volume and we're bringing it over the other side. So now I'm going to just plug in the values as I've got them up here. I've got the 4.00 moles, I've got the value of R, along with all the units, of course, times 303 K over 0.800 litres. And what you're going to see here is that the litres will cancel, the moles will cancel, the kelvins will cancel, and we'll be left with atmospheres. Now that would give us 124.3209 atmospheres as our answer, but we know that we need this to be in torr, and we need to know the conversion then, and it's 760 torr for 1 atmosphere. So we do that times 760 torr over 1 atmosphere, and that gives us our value for pressure, 9.45 times 10 to the 4 torr. Now the number of significant figures is going to be based on the smallest number of significant figures in the multiplication, which is 3, which is why I come out to 9.45 times 10 to the 4th torr as my answer.